Well, hello everyone, and thank you for attending today's webinar, How to Drive Business Value with JBoss BRMS from Red Hat, Vizuri, and Carahsoft. I'm now going to pass you off to Ben Johan.
Welcome everybody. Thanks, Matt. As you see, we're going to talk today about how to drive business value with JBoss BRMS. Just a quick introduction of myself. My name is Ben Johan Vanderwalt. I'm a solutions architect at Vizuri, and I'm working in our business process and rules practice. And we're dealing on a day-to-day basis with clients wanting to implement a rule engine or a business process engine into their enterprise system. We have a packed agenda for today, so I'm going to try and go through it as fast as I can, but in as much detail as possible. Feel free to ask any questions. We will try and answer those questions at the end of the session. Type them in the chat window. We're going to look at when to use a rule solution, what's the importance of a well-defined vocabulary, look at some examples of rule authoring tools with Red Hat BRMS, and then the fun part, we're going to look at a demo of a dynamic questionnaire. So anybody, can you tell me what you see on the screen? Do you know what that is? Feel free to type something in your chat window. I'll see who's making the best or the most accurate guess. Yep, I see some come in. Give me some more suggestions. Well, for the ones who didn't know, what you're looking at is a typical wire stripper, or more specific, a Cat5 insulation remover tool. Just like this tool, if you don't know what it is, you cannot use it. And even if you know how to use it, it's not going to make you a network architect. The same thing with business rules. If you don't know what it is, you're not going to know how to use it. And even if you know how to use it, it's not going to make you a rules expert. In today's session, we're really going to address the soft skills that is required to start a business rule project. So what does a rule look like? Let's look at that a little bit more in detail. The business definition would be rules are intended to assert business structure or to control or influence business behavior. I like to explain things using examples, and what that basically means is it's your typical regulations, laws, policies that are handed down for developers to implement or business analysts to interpret and pass down to developers. You also have complicated business logic, which requires subject matter experts to explain what it is and how to use it. It's not uncommon for me to sit across the table, especially when we deal with insurance companies, to deal with medical doctors or scientists on the other side of the table, helping us to explain very complex business rules. You also get your typical company policies and procedures. So what does rules look like? It can be a long laundry list of seemingly disconnected criteria that is used to validate a course of action. Again, some good examples. As you're going to see later down in our demo, it can be something like a set of questions that needs to be answered for insurance policy, a combination of readings, validations to determine error or failure of something specific, or in the medical industry, a bunch of medical conditions to determine the approval or denial of a life insurance policy. Now, before we continue, we now know what a rule is and how it should typically look like on the requirement side of it, but how would these rules be implemented? So the basic rule anatomy is as follows. You get two sides, the left side and the right side. Or in short, we call it the left-hand side and the right-hand side. The when side, which is the conditional part, and the right-hand side, which is the action or consequence side. All constraints get written on the left-hand side. Now look at my little example. As you can see here, we've put two constraints on an object called holiday. In this case, the holiday has two attributes, month and day. As you can see here, if a holiday month equals July and the day is 4th, then on the action side, we're going to take some action. And in this case, we're going to send out a notification. The language that we use typically is called MVAL for short, but it actually stands for MV Flex Expression Language. It is a declarative language which we're going to talk a bit more about further down in the slides. Now just some caution. As you note on the right hand side, I didn't include any additional if-else statements. It is very important in the action side just to take action. Don't go ahead and add additional conditions. A rule should be atomic. When this, then do this. Not when do this, maybe do this. This is a big trap that developers starting on a new rule project fall in. They follow their typical development mind and process, and they try to add additional if-else statements. This eventually makes debugging rules very complicated further down the line. If you need to add additional if-else statements, that will be a signal or a trigger to say, hey, maybe I need to add a second rule. So now we know what a rule looks like. What makes a rule approach different? The number one difference is rules are authored separately. Rules are not intertwined into the current plumbing of your existing IT infrastructure, IT systems. It is kept separately in a separate repository, and it's authored separately, not within your Java code or C# code or C++ code. And it will not be affected by any surrounding IT systems, or any IT systems will be affected by it. How are rules expressed? Rules are using a declarative language. Declarative is saying what you want to do, not how. Typically in the programming world, everything is about how, using a programming language like Java. In rules, we use a declarative language. And I'm going to talk a little bit more about declarative and imperative a little later. Using a declarative language just makes reading rules and their definitions much easier, and it makes it possible to share it among more than just developers. Developers may tweak rules or write them in the first round, but after that, due to the fact that they're easy readable, makes it possible for business analysts to go and look at them, tweak them, and eventually, take them over from developers. So imperative and declarative. Two fancy words, but what does it really mean? Imperative is typically your programming language where you follow a specific set of steps. Java, C#. Now I didn't give an example for declarative. Can any of you think of a declarative language? Go ahead, type something in the chat window. Let's see what you can come up with. Yep, I see some answers. So here are a few examples. SQL. I'm sure you guys have seen SQL before. It's been around for ages. SQL is typically a declarative language used to interrogate a database. Regular expression has been around forever. HTML, the whole internet runs on HTML. As you can see, these languages never tells you what to do. It's not like a program like Java. It declares what. HTML tells you what, not how. So I'm going to hammer on this over and over, but whenever you think of rules, think of what, not how. And this is particularly important for the developers, because I know, when you start a new rules project, you're going to try and attempt to attack it the same way you've been doing other projects. So let's look at motivations for a rule-based solution. The moment you deal with complex problems, you should think of a typical or a possibility for a rules project. When you have conditions where you have a lot of volatile requirements, you have to deal with subject matter experts to get the answers, complex scenarios, those should all be indications that I may have to need a rule engine to solve this problem. And especially, you have environments where decisions are made fast and you need to react on those decisions, even though the information is only partial. I can just see the developer's face when They just finished a sprint after a week and the project manager say, well, can you go redo this piece? That's the typical scenario with rules. However, the impact on rules is different than a typical software development life cycle using Java or C#. What's the traditional approach for implementing rules? It is typically buried in code. It's intertwined with the plumbing of multiple programs, multiple layers. After rules are implemented traditionally, it's a black box. Nobody knows what's going on inside it. It works, just don't touch it. We've all been in that situation when the subject matter expert retires and nobody wants to take over the code because nobody wants to change it because the potential will not work after you've touched it. Here is a typical N-tier enterprise system, and with clients that I work with, it wasn't very uncommon to find rules that is implemented in the client tier, the presentation tier, some in the business tier, even the integration tier, and of course the database. I've seen cases where one specific rule was implemented in at least 3 of those tiers. Can you imagine if your company decides tomorrow that we're going to replace the presentation layer with something different? If you use Spring and we're going to move to Angular, you basically removed or destroyed all those rules and they're going to have to be re-implemented. However, the people who did it moved on. They're not there anymore. Can you imagine the pain and suffering going through that? Lost in translation. When rules come down from the top, business people need to interpret those regulations, those laws and policies. They need to develop requirements. Those requirements have to be interpreted by developers. The same requirements have to be interpreted by analysts. You guys see where I'm going. Any of you played the game telephone? See the telephone on the picture there? It's exactly the same case. Whatever the first guy whispered in your ear is not what the last guy is going to hear. The same thing with rules. We really would like to reduce these translation layers. And that's typically what you find in a traditional system. There were so many translations that what the system eventually implemented is not the same as what the original requirement was. Now just a quick note, the rule engine is not a fix-all. There are scenarios where I would suggest not to implement a rule engine. A few cases are, for instance, where you have business logic but it hasn't changed for years. There's no point in implementing a rule engine on logic that never changes. Leave it as it is. You also have cases where there's a very strict control in the execution order. No point in using a rule engine. As I said, a rule engine has a bunch of rules and all those rules are atomic. Rules are not depending on one another. When you need a strict control and execution order, I would say stick with a programming language like Java or C++.